Welcome to my presentation. In this presentation, we shall see how to solve an application problem related to derivatives. In here, we have the description of the problem is as follows. Suppose the demand for a certain item is given by this function d of p. Demand of a particular the price of a particular item is given as negative 3p squared minus 5p plus 300, where p represents the price of the item in dollars. What we want to do is we want to find the rate of change of demand with respect to price. So it is we can use the limits, we can use the techniques which we have used so far to be able to solve these types of problems. So as a first step, we're going to write the formula down the way we know it. The slope, or the first derivative of a function, we know is given to us as limit as h approaches 0. The numerator part is the function f of x plus h minus f of x, the whole thing divided by h, and that is the formula we know. As a second step, we're going to substitute the given function into this formula, and therefore we can write this one out as the limit as h approaches 0. We can write the numerator part as negative 3 times p plus h, the whole thing raised to the power of 2, minus 5 times p plus h plus 300. That is the first part of that formula. We'll put a bracket around it. And the second part of the formula is, open brackets, minus 3p squared minus 5p plus 300. That is the given function. And then this whole thing divided by h, and we're going to put a bracket around all of that. Now, as a third step, we're going to simplify the math. We're going to simplify the math in this step. So therefore, the way we do that is as follows. Limit as h approaches 0. We're going to write the numerator part as follows. We're going to expand the numerator part. Negative 3 times p plus h, the whole squared, is p squared plus 2 times ph plus h squared. That is the way we can expand that. Minus, we're going to distribute this 5 to every one of the terms inside the parentheses. 5 times p is 5p, 5 times h is negative 5h, plus 300. That is what we have in that part. And in the denominator part, and the second part of the numerator, we go to distribute the negative sign to every one of the terms inside the brackets. So we have negative times negative is a positive, 3p squared, like that. Negative times negative is a positive, 5p. Negative times a positive is a negative, which is a 300, and therefore the whole thing divided by h, and we're going to close these brackets, and I'm going to take this part of this out here. Now, we can simplify the numerator some more as follows. The limit as h approaches 0, we can write the numerator part as follows. We're going to distribute the negative 3 to every one of the terms inside the parentheses, like this. Negative 3p squared minus 6ph minus 3h squared. All we did is distribute the negative 3 to every one of the terms inside the parentheses and write the rest of the terms in the numerator as is. Minus 5p minus 5h plus 300, and then plus 3p squared plus 5p minus 300, the whole thing divided by h. Now, there are some terms which are which are similar but opposite in sign. 3p squared, negative 3p squared, this cancels out. Then we have 5p and negative 5p, that cancels out. Positive 300, negative 300, that cancels out. So now we are left with, we can simplify this some more as follows. So limit as h approaches 0, we can pull out h as common in here. As we can see, we have a negative 6ph, negative 3h squared, negative 5h. Therefore, the negative sign is common, so negative h is common in the numerator. So if I pull it out, I'm left with 6p, and then I have a positive 3h, and I have a positive 5, the whole thing divided by h. The reason I pulled out h is because I have an h in the denominator, so I can cancel them out. So therefore, when I simplify it some more, I can write this in its simplified form as limit as h approaches 0. We can write this one as negative 6p plus limit of 3h as limit of negative 3h as h approaches 0 plus the limit of this constant number negative 5 as h approaches 0, because here we have a negative sign, so I in fact distributed the negative sign to every one of the terms and then wrote it out as separate limits like this. Now we can apply the limits, so therefore the limit of this function negative 6p as h approaches 0 is going to be equal to negative 6p. Limit of negative 3h as h approaches 0 is going to go to 0, so that is 0. And the limit of a constant number where as h approaches 0 is going to remain as a constant number, and therefore this value here is going to be equal to negative 6p minus 5. Negative 6p minus 5. Therefore, the function which we had, and let me go back and then tie it back into the problem. The problem we had was as follows. The demand for a certain item is given to us by this function d of p. If I were to write it out as, if d of p is a function given to us as negative 3p squared minus 5p plus 300, the first derivative of that function, or the rate of change, we needed to find the rate of change of demand with respect to price. So we can find that by finding the first derivative of this function, and that is going to be equal to negative 6p minus 5, and that is the way we can do this, and this is our answer. This is the way we can solve application related problems using limits, and using limits to find the derivative of these types of functions. In my next presentation, we shall see some more application problems related to derivatives using limits.